Okay, welcome to the Arborist Call for the 16th of May. We'll have core team updates, research and implementation updates. There are no agenda items today, and we'll just have open announcements and open discussion. What are Arborist Calls? These are calls that we hold every 2 weeks to discuss the Zcash protocol. It's focused on developers and engineers who are working on enhancements to the protocol to discuss upgrade timelines and process, R&D efforts, and design and implementation of new protocol features. The idea is to make core protocol development more accessible for the Zcash community and to provide transparency into everything that we're doing. Anybody can join these calls if you want to do so, learn more details, register for them. You can point your browser at zcasharborist.org. And after you've attended a few calls, if you'd like to suggest a topic for discussion or give a presentation to the call, please reach out to arboristcall@zfnd.org and we can arrange that. Other ways to get involved in Zcash are applying for a community grant, and you can point your browser at zcashcommunitygrants.org. And you can also join the Zcash R&D Discord, which is where a lot of the engineers that work on Zcash hang out. For less technical topics, there's the Zcash Community Forum, which is always a spicy and exciting place to hang out. And you can find all these links by pointing your browser at zcasharborist.org. Right, let's start off with ECC. And I am guessing that Chris is in the hot seat today.
Okay, found my mute button. All right. So since the last Arborist call, obviously last week was a wonderful ZCon. And this week we have been spending most of our effort catching up on wallet maintenance tasks that have arisen and bug fixing since the launch of the Zcash wallet apps. The other piece that we're actively engaged with is working with Binance on adding an RPC method that they're requiring for Zcashd to allow them to essentially check the text address conversions. So we've gone back and forth on this a bit, and we've decided to just go ahead and add it because otherwise they are not willing to proceed. So we're doing that maintenance. Apart from that, we've spent some additional time talking about NU6 and discussing things related to NU6 memos, and also there was something else that we worked on yesterday that was similar in character, but I'm blanking on it now. So anyway, lots of stuff going on across the stack of.
Was that it? Was that in the Zcash bits we were talking about there, or NU6 specifically?
I'm losing track of all the things that we're doing, and I didn't take notes in advance of this meeting. So if you remember other things that I haven't mentioned, please speak up.
Yeah, we did have some discussion yesterday around yesterday, and then a bit today as well, around how currency conversion in Zcash was going to work.
That was the thing that I was remembering.
Yeah,
I was forgetting.
So coming up with an approach that enables access to exchange rates in a verifiable way, so not relying on intermediate caching in LightWallet-D in a way that LightWallet-D could manipulate, while also ideally hiding not revealing information to the currency servers that is unnecessary to do so, and being resistant to currency exchange rate manipulation. So we've had some thoughts around that, and mostly it seems to be a working around the fact that most cryptocurrency exchange rate API providers don't consider this to be a thing that they care about. So there's a little bit of work to be done to do that on top of the APIs that exist, but it seems feasible.
Cool. Any questions for ECC team?
I've got some stuff we could chat about memos in the open discussion section, but we won't do that right here.
Okay, let's move on to Zebra. I think Alfredo has got it this week.
Yes, can you hear me?
Yeah.
Okay, cool. So yeah, last week it was CCon. Most of the Zebra team was either a panelist or a speaker or helping with the logistic with that. I think it was Monday that we released Zebra 1.7.0 before CCon started, which mainly highlights the reg test and the custom testnet support. Yeah, so then this week we reverted back the end of support date. We, in the last Arborist call, I think we mentioned it that we were extending the end of support of Zebra from 16 weeks to 20 weeks, but there were some concerns about that, so we reverted back to 16 weeks, which is the same Zcash did as. We are working in a reg test tutorial for people to start using that new feature Zebra has. We resume the work of upgrading what we call the ACC dependencies from Zebra, which are the Zcash primitive, the Zcash client backend, the Zcash proofs, and all those kind of dependencies that we are behind right now in Zebra. And this upgrade is not trivial, so it is taking us some time, but I think we are getting there. And finally, I think Mark is working on a bug reported by Andrew Arnott about the get3 state support, the get3 state RPC method. Yes, there is a PR open for that, so I think that is in the right direction. Yeah, that's it for today. Since the last Arborist call, it was a short update because of the CCon, but I guess were able to do some stuff.
Cool. Thanks, Alfredo. Any questions for the Zcash team? Zcash Foundation team? Okay, let's move on to talk about Zcash dedeprecation. I guess in future we should figure out who's going to do this and maybe alternate between the two teams. I'm gonna pick on Strad.
Woo! Progress continues to be made. There's been some work on further discussion around how the various services are going to work, like how the composition and distribution of responsibilities between what's going to be doing scanning and what's doing indexing and what those mean. There's been some further figuring out of that, and then identification of further work that needs to be done to enumerate the various kinds of data that are necessary for those services so that people can start building them. There's been work done in the depths of the transparent script logic, so people are figuring out the work necessary to take the fledgling Rust implementation of the script engine and verification and production logic that's being ported over from C++ and figuring out how to integrate that into the Zcash script Rust library, which is currently a thin wrapper around the C++ script engine. So there's some finagling necessary to get that stack to work. But once that is once that is working, then the process of building and setting up the Rust piece will be significantly easier, because it'll be possible to do cross testing between the current of anything that the Rust generator is producing against the existing C++ verifier, up until such times we're confident that it can be a direct replacement. Although for safety reasons, it's most likely that even when we are confident that the Rust implementation is feature complete, we'll probably still want to have a switch over in a network upgrade, similar to what we've done in the past for switching core cryptographic dependencies such as libsodium switching from libsodium for 825.49 verification to 825.49 Zebra, just to make sure that there's no potential issues in that regard. And then, as Chris mentioned before, there's continual bug fixing going on in the Zcash client backend stack, and the dependencies underneath it, which of course are necessary to be working for an eventual full node wallet as well. And then I think there's a bit of work going on with potentially looking at different ways that we can start putting together a initial like CLI binaries and things that people can start iterating on for the purposes of doing wallet development work of the wallet services. But that's stuff that will be more relevant in future Arborist calls. Is there anything I'm forgetting? I think that's a fair bit for the last 2 weeks. So,
yeah. Any questions on that?
There was one other thing that I remembered, which is actually something that you've been working on, Strad, which is a relatively significant refactoring of the the Zcash primitives transaction builder.
Oh yes, it blanks from my memory because it's all I spend my time on at the moment, other than everything else I spend my time on. But that is so for the purpose of enabling. I think I may have mentioned this in the previous Arborist call, but yeah, for the purpose of enabling specifically the sapling, crypto, and related dependencies to be made unnecessary. So you're not required to depend on them if you aren't doing anything explicitly with sapling. So the canonical case being Brave, who are deploying Transparent and Orchard, but not going to be deploying like the ability to store funds in and spend to sapling. And so eliminating all that stack of dependencies makes the deployment process of dependency auditing and whatnot far simpler. So there's work going on to essentially tease apart the APIs so that if you don't have those dependencies there, then you just can't like add sapling outputs to the builder and so on and so forth. So it's a bunch of staring at the type system, and it's slowly coming together. But yeah, thus far it hasn't. There isn't an effect on anyone who is using just the transaction type directly. I'm hoping to try and keep it that way. And so it's mostly just if you're using the transaction building APIs or the authorization stuff underneath, essentially in the wallet code, is where most of the effects are occurring. Yeah. The other benefit of this refactor is, as a side effect, the effect on the transaction builder in the Zcash primitives crate will be such that signature production will now be a separate explicit step rather than bundled into the build process, which will make integration with hardware wallet signing stacks easier.
Cool. Any questions relating to Zcash deprecation? Okay, let's move on. I don't see anybody here from the Sustainability Fund, so we'll skip that. Trailing finality, any updates there, Dara? And appreciate that no is a perfectly valid answer.
No updates.
Moving on to Zcash shielded assets, we also don't have anybody here for that. So we'll finish off the research and implementation updates with Frost, and I think it's Conrado this week. No, we can't hear you, Conrado. Let's move on.
While fixing the technical difficulties, I can give a very brief update on ZSAs, which is that we had a meeting earlier this week. So we've had meetings. So we, with the Zip editor's hat on, have been having regular meetings for months, if not the full past year, with the Kedit team working on the specification design and whatnot. That meeting slot has now been transitioned into an integration related meeting, so more focused on the process of landing the backlog of things into the various code bases. So the meeting on Tuesday was focused on the it was focused on the initial pieces that are being that need to be landed in note encryption, some discussion about the how to gadgets changes, and then there was one piece that I am forgetting what it was that we discussed, but there was some notes posted, I think, in the Discord.
Was it the interaction between ZSAs and the memo changes for NU6?
Yeah, we discussed that briefly. I think and there was some.
I'll try and find the notes.
I found the notes.
Okay.
Yeah, there was some discussions around things like, can asset desk be zero length, and then some implementation level discussions about what it is that nodes need to be storing and what state full validators need to be tracking. So, for instance, the ZIP227, which handles the ZSA issuance, currently only requires full nodes to track finalized assets, i.e. assets for which no more issuance transactions are allowed to be created, so they have to be rejected from consensus. But it's also desirable for ZIP 209 style tracking of individual assets to be done, i.e. the amount of that has been issued by any asset thus far, to ensure that if there were, for the same reason that we have in the current consensus rules, a requirement that you don't allow any of the existing shielded pool values to go negative in a transaction, which would be which would imply some counterfeiting bug inside the circuit, but we just don't allow that to happen in the consensus rules to be a sort of a bulwark between different shielded protocols. And so you should have a similar rule for the individual assets, which implies that the assets themselves need to be tracked. And so there were some discussions around like all assets that have been issued need to be tracked. And then there's a question of how that impacts issuance fee, the fee for defining a new asset versus the fee for issuing an asset that has already been defined, and whether there should be a distinction. So there's discussions ongoing sort of in the realm of what's the effect of tracking all of the state on full nodes and the network as a whole.
Yeah, and that condition, whether the pool would need to be checked to see whether it went negative. So initially, it only applies to burns because that's the only thing because there's no equivalent of transparent ZSAs, it would only apply to burns. But you can imagine, for example, that in future we would have some protocol that upgraded Orchard, and you might have a value revealing turnstile between those two.
Yeah, say if we migrated to post-quantum sound ZK snarks, And we're enforcing a post-quantum sound payment protocol that you would want to bulwark that from the pre-quantum secure side. And that would be a point where you would want these checks to be enforced.
Yeah, I think we also had a discussion, and not specifically with the Kedit team, but among ourselves about the issue of how you name assets, and sort of how to make sure that there are no collisions. I mean, the issuance key to a certain extent prevents collisions, but that doesn't address the issue of what you show to the user. So we wrote down some design considerations for that.
Yeah, sort of from a wallet UX perspective, because you can think of the ZSAs as being a baseline protocol on top of which a variety of different assets and asset usages are possible, and how individual wallets distinguish those is important for UX, and how wallets determine what asset they receive, given that we have a protocol where anyone can be sent any asset. And all you learn from that detection phase is the identifier that's in the note plaintext. So yeah, there are a couple of follow-on ideas related to that may result in some slight changes to ZIP 226 in terms of what gets stored in note plaintext, perhaps, or it might be that we satisfy ourselves with the UX around things as they are.
And we might end up having another zip for sort of recommendations for how wallets implement CSAs, or fold that into zip 315.
Yeah, it may make sense as like
shouldn't block the existing work on zip 315.
Yeah, it would either be an amendment to 315 or a sort of like if you were doing ZSAs in addition to the considerations in 315.
Any other questions on ZSAs? Let's move back to Frost. And Conrado reckons his mic is working.
Is it working now?
Yeah, we can hear you.
Yeah, I don't know what's happened today. Sorry about that. So on the last 2 weeks, we've been mostly focusing on Zcon. We did a presentation there, explaining what we did since Zcon. We presented a demo. This demo can almost run it yourself if you want to. There's one mass PR that we need. It's basically done. I just need to review something and merge it. But after that's done, you can run the demo yourself. And this demo allows you to run Frost in different machines across different places by using a server that helps people sending messages back and forth. So what we're working now are doing some refactorings to the server to help prepare for the rest of this implementation, which is basically turning the server to something that's production ready. So we need to do some user registration mechanism, we need to add encryption, authentication, etc. So we're working on that. And Nether is finishing the refresh shares functionality in the main Frost crate. It's basically done. I think she's working on just getting some tests fixed. And that's mostly it. Yeah.
Any questions for Conrado? Okay. Let's move on to open announcements.
I realized that I said there was no news for TFL, but I did a whole presentation at ZCon 5 on TFL, which took a lot of time to prepare. So, oops, hang on. Sorry, I had that accidentally playing in the background. It's distracting me. Yeah, I'll put the URL for that in the chat.
And yeah, if you want to, if anybody's watching wants to find all these presentations, they're on the Zcash Foundation YouTube channel. So you'll find them all there. I'm gonna share something very quickly, which I think is really cool. It's a project that Elise has been working on for a little while, and it's as you can see, an educational workbook entitled "My First Zcash," and it's basically talking about money and decentralized, cryptocurrencies, and then an introduction to Zcash, and a bunch of details. And it is such a cool piece of design. It's been a real
it's fantastic.
It's been a real collaborative effort with people from across the Zcash community chipping in and completing various bits of it. So yeah, I'd recommend checking that out.
And if you have any comments, it's on GitHub. So just file an issue, as I did.
Yeah, some amazing artwork as well. I think it's just really, 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 really cool. But yeah, any other announcements or news that anybody wants to share? If not, let's move on to open discussion. Cool. I'll stop sharing. There's no point in sharing this. Yes, Strad, I think you want to talk about something?
Yes, I have a topic that will get a little cryptography and nerdy if people want to get into that.
Absolutely.
So regarding the memo bundles zip that we've been working on, Han raised an interesting point that we considered at multiple points over the various years that we've been thinking about this, and I'm glad that they raised it again to sort of bring it back to the forefront of thought regarding how these memo bundle keys are derived. And so in the initial draft that we put together, it was sort of the simplest switch from what we currently have, which is just replace the memo field in a note plaintext with a key that can be used to decrypt memo bundle data that is elsewhere in the transaction. With the idea being that then you can have, in particular, you can share memos between recipients and also between shielded pools. So you can have a memo that a sapling output and an orchard output can both see, because you just give them the same key. So Han's question was, why embed, instead of embedding the key in the note plaintext, why not derive it from the common shared secret? And so to give a brief explanation of what that means from a cryptographic perspective, when you do trial decryption right now, you scan with your incoming viewing key, and the process of scanning is that you're deriving a shared secret between some ephemeral data that's provided in the transaction by the sender and your static data that's in that's your IVK. And then from that shared secret, you derive a symmetric key, and that symmetric key is then used to decrypt the note ciphertext. And if that decryption succeeds, then the note is for you. The output is for you. So that's what we mean when we say trial decryption. There's no reason why you can't derive multiple keys from that shared secret. If you're going to do so, you need to do so in a specific way. So if we took this approach, it would mean just completely changing the way that the KDF is currently done. But that's fine. That's cryptography knows how to do that. The question is
we in fact did that for Sprout. We derived 2 keys. Carry on.
Yeah. So the question really is one of the effect on the transaction as a whole. So we've done a bit of discussion around this, and sort of there are 3 things that essentially need resolving when it comes down to this this like particular design question. One is, do we gain capabilities with by deriving lemma keys from the KDF? Secondly, do we lose capabilities by deriving keys from the KDF rather than embedding them directly? And three, what is the effect on distinguishability of the resulting transactions? So if you embed the memo key in the note plaintext, you can share a key between multiple outputs because you can just embed the same key in multiple outputs. If the memo key for a recipient is derived from their shared secret, then each output has a unique memo key, the same way that currently each output has its own memo. Now, you can still do shared memos in that design. You just have to do them indirectly, where each recipient is given a memo, and that memo, the only thing it contains is a structured memo, so no text, but just essentially a thing that says, oh, by the way, you've been given a memo key to decrypt some other memo in the bundle, and you give everyone the same key there. And so it's not impossible to do shared memos. However, if you do that, then there are two problems that I see from this. One is that it requires a bunch of additional memos, so you're no longer saving data relative to embedding the key material in the note plaintext, because to embed the key in the note plaintext, it's an extra 32 bytes per recipient, and to give everyone a common memo key, that's an extra 32 bytes per recipient plus in the memo bundle part, because you have to give them that data somewhere. So
and you have to give it them separately for each recipient because they have different keys. Because they have different memo keys, exactly. So if you use the KDF approach, then in the shared memo case, where in the limit of you're giving one memo to every recipient, you are saving no data whatsoever in this approach. Even though the note plaintexts are then technically shorter, overall it costs you the exact same amount of data in a transaction. Where you would save data is in you are sending unique memos to individuals, or like one memo to one individual and none to any of the other outputs. But then we get to the question of identifiability, because the memo chunks required to send key material are going to be quite small, versus the memo chunks, if we want to still do like minimum of 5 12-byte memos, if that's data that gets all used, then you've got this distribution of memo chunk sizes within the memo bundle that potentially then create an identifiable distinguisher between people who are sharing memos and people who are not. Transactions that are sharing memos and transactions that aren't. So that's a potential issue that we need to decide whether we're interested in dealing with. I'll give you my intuition. I think the potential need for indirection in some cases is too complicated, and it makes it more difficult to potentially prove things in the circuit about memos if we wanted to do that in future extension. So I prefer the design that we were originally thinking of, just with the extra 32 bytes in the 32 byte key in the note plaintext.
Now, on the flip side, also I think Chris, you might be muted.
Oh, yep, yeah. I've sort of been thinking about this a bunch since yesterday, and I think the complexity argument is the one that mostly wins me over. Is that the flexibility offered by including the memo key in the note plaintext, and the fact that it's very straightforward to analyze, I think it's more readily implementable, and it provides a lot of utility without a huge lift. and particularly in terms of, distinguishability analysis.
Yeah. Now on
Yeah,
the flip,
same.
yeah. Now on the flip side, just to offer an alternative point here,
On the gripping hand.
Yep. An advantage of using the KDF approach is that it takes a step towards more granular viewing payment disclosure capabilities. So if the wallet ecosystem standardizes on the memos are encrypted with a key that is given to you in the note plaintext, then what that means is if you have the capability to view a note plaintext, you are inherently being given the capability to view any memo bundles that the keys included in there can include. Whereas if the keys, if in the KDF approach, where you have the shared secret and then you derive two, in particular, independent keys from that same shared secret, then there exists a secret that you can include in a payment disclosure that will disclose the note plaintext, but not disclose the memo. Now, the caveat to that is that particular key only discloses the note value. It doesn't disclose the recipient because the recipient data is stored in the out ciphertext. And if you have a capability to decrypt the out ciphertext, then you gain the capability to recover the shared secret, and therefore both keys that you would do in the KDF context.
Yes, it's complicated to reason about. Chris.
Yeah. So is there a possibility, like the inevitable question is, why not both? Could one do the KDF to produce your two keys, but then XOR the memo, the derived part for the memo with the memo key, and therefore you get the separation, but you're essentially just decrypting the memo key that you then use to go to decrypt the memos.
Chris, if the argument against option B is that it's too complicated, then option A plus B is also too complicated.
Yeah. The point I was going to raise there is that
or AX or B.
Yeah. AX or B, yes.
My answer to that was something I was about to mention before you asked the question, which is that there's a thing that we do need to consider with the way that memo bundles work is that there is nothing preventing you from encrypting memo bundles to whatever key you want. So in particular, even with a note plaintext that has an embedded memo key slot, if you don't fill that slot, it is possible to create a transaction where the note data is recoverable from on-chain, but the memo data is not, by instead using a memo key that is derived in some other fashion or just generated from random and provided to the recipient out of band.
Strad anticipated my point.
Yeah. So the answer there is, if the KDF structure is such that you can derive those keys, then there's nothing preventing you from encrypting something to that KDF key in addition to any key that was in the main slot. And in fact, that could be a slightly more efficient way to be able to give a recipient two memos, one of which is definitely for them, and the other one is a potentially shared memo. So
you're muted, Chris. Still muted.
At mute.
If you put a key into the note plaintext, then you don't have to do anything with that key. If one were to specify this KDF, you would just derive your other key based upon the KDF and take and use that.
Right. And, so that's my point.
But that doesn't have to be consensus.
Yeah, it's entirely outside of consensus.
Exactly. And it's wallet standards, because the wallets need to know where to look. But at least for how regular wallets will be working, as I said before, the act of receiving a note is the ability to decrypt the note plaintext. What you can decrypt from memos is completely irrelevant, and so it's not a factor in the ability to receive funds. Once you have detected something is for you, then you can go, okay, well, I'm going to look if there's a memo key inside the note plaintext, I'm going to decrypt with that. And then maybe I also, because some wallets might be encrypted to the other one, go and encrypt with decrypt with the KDF key as well and just check if there's anything under that.
Yep.
But at that point, the amount of work that you're doing is linear in the number of transactions involving your wallet, because you've already filtered from the chain based on the receiving a note as the sort of the flag that this transaction was for you. Although that being said, there's nothing preventing someone from making the note to, creating a transaction wherein an output is not decryptable by you, but memo data is, because they can just, if they can derive a key that you in theory could derive, then they could use it.
But by the way, our protocol discussions are always this dense. So you have now an insight into what we do all day. Well, in the best case, when we're not implementing silly features about transparent addresses.
So this is a good point to pause, and because we on the ECC team have been discussing this a bunch, but can we get input from ZF folks?
Or anyone else who has thoughts on on this discussion?
I don't think I have. I need to think about this more, and I need to study the memo zip a bit more. But the impression that I have is also that your original approach is simpler. The KDF one seems too complex, and I'm not sure if it's worth it.
I mean, if it helps, so for Sprout we had two note plain text in each join split, and I regretted that decision. Because why did I regret that decision? Oh, it was because it was more difficult to do payment disclosures as a result. So we do need to think about that.
Right.
Yeah, the ability to do granular disclosures, like more like sub part granular disclosures, does not necessarily mean that doing so is a useful idea.
Yeah, I think so. In the Sprout case, you ended up disclosing potentially the change as well, which you normally don't want to do. So yeah, and that's why we changed it back to the KDF only driving one key for sapling.
Yeah.
Also because it's slightly simpler to analyze.
Yeah. So.
Yeah.
I find this idea
tempting.
I find the idea tempting, but it does seem like it's too complicated for the feature that we're adding.
Yeah, the reason I think that Han had suggested this was that he was saying, well, in that case, we can save a whole 512 bytes from each output, as opposed to only 480 or whatever it is, 476, something like that.
I don't think it ends up smaller for a significant portion of use cases. So
yeah, I mean, so I think that on average, having the 32-byte memo key with each output, we're already going to be saving essentially 450 bytes or something like that for the standard transaction, because I think the standard will be that there is one memo associated. We could make it the standard that there's two memos associated, and then we won't be saving anything, but standard of one memo seems, one or two is standard is one. Two is probably going to be common because there are more and more wallets that are putting extra metadata into their change memos, but I don't think that that's going to be, one versus two is not going to be substantially distinguishable there. And in those cases, in an amortized sense, we'll be saving a bunch of space on chain anyway. So that's good enough for now.
Yeah, and the question then of, in the case, if you in the two output case, the benefit. So actually, here is an example of something where sharing is a significant benefit here. Y Wallet, Hans Wallet, actually duplicates memos right now. When it generates change in multiple, so in transactions where there are more than two outputs, you have the real the recipient output in whichever pool it's going to the recipient, potentially several pools, and then potentially several change outputs, one per pool. And currently what Y-Wallet does is it duplicates a memo mentioning something about that in each of the change outputs. So purely in that kind of use case, sharing those memos together is something you would want to do. And if the KDF approach is taken, then you immediately have to pay the cost that you were trying to save in the first place for by not storing the memos in the note plain texts.
Yep, that's a good argument as well.
Yeah, it only saves data when you in the case where you have explicitly distinct memos, and one of the two motivations here is to enable not having distinct memos.
Yep. I have a
it also, since we presume that things like authenticated reply to, well, I guess maybe that's, if you have an authenticated reply to, you can share that authenticated reply to with multiple recipients
yes,
easily via the sharing.
Yeah, and that piece, for instance, is something where potentially nested memos are a useful idea when you think about imagine that you're creating a transaction which has, say, 10 recipients plus change, and you want to send an authenticated reply to address to each of them. But the authenticated reply to part is a huge component, like it's hundreds of bytes. So you could include that once in a memo bundle, and then per recipient have a per recipient memo that's a structured memo which has the per recipient memo piece, and then a memo key that lets them decrypt the other memo that's the common memo with the authenticated reply to it. So then you're only paying the authenticated reply to once, in effectively 10 distinct, otherwise distinct memos. So there is a UX question of how that compositionality is shown to users in these sort of nested memo cases. But there, this is sort of thing where what you would probably do is just at the ZIP315 style level of how wallets behave with this, sort of at the UX level, you would say, you can do these arbitrarily kind of nested things. You shouldn't. If you're going to do nested things, consider like only having one text memo across all of the nesting and keeping the other stuff for metadata, that sort of thing.
From the perspective of the individual recipient of that transaction, it's pretty straightforward what the wallet should do, which is just show them everything that they can see, right?
Yes, with the caveat of like, what does it mean to have, if you have a memo within another nested memo
if the ordering is well defined.
Yeah, like the order, it forms a tree. So the ordering, there is some level of ordering you can define. But like, for instance, there's the problem right now. Well, there was a problem in Zashi, which has just been fixed in the recent update, where if two memos were decryptable, they were concatenated. And the order they were concatenated in was sort of semi-arbitrary because it depends on the ordering within the transactions.
Yeah, that was a bug, though.
Yeah, that was a bug. But the more general case of if you can see like multiple separate text strings, you can imagine that you don't actually want them to be directly ever concatenated or treated in that way, but ordering could be a concern there. So it's mostly just about pinning down the behavior of what wallets do there.
I mean, if I've learned anything, it's that pinning down the behavior of what wallets do is a lot harder than pinning down the consensus protocol. And you would think it's the other way around, but no, because the consensus protocol has to be right, it's actually easier to specify, which is weird. I've got a fortune cookie here. It says the secret of success is to have a constant goal. There we go. The constant goal is privacy.
A constant time goal.
Yeah. And on that note, do we have any other announcements?
Or any other topics for discussion? If not, we will say good night, or good afternoon, or good evening, or good morning, depending upon where you are. And we'll see you at the next Arborist call in 2 weeks in the earlier time slot of 1500 hours UTC.
Yes, and pay attention to that time, not necessarily the time that is on the calendar.
As always. I look forward to the day when that doesn't come up.
See you.
Right. Thank you, everybody. And see you in a couple of weeks.
See ya.
Bye for now.
See ya.
Bye.
Thank you.